more fun math. Radicals, operations with radicals. I think what we're going to do is we're going to, let me look through my notes. I'm going to simplify. I'm going to simplify cubes. I'm going to do a little more multiplication. Do a little addition and subtraction. We're going to do some rationalizing. And that's it. We're done. All over with. Shouldn't be very long. About a half an hour. Half an hour that you will never, ever, ever get back in your life. But maybe, just maybe, you'll be a little bit smarter for it. All right, so here we go. Let's see what we got. We're going to draw, grab some red, grab some skinny red. All right, this one shouldn't be too difficult because, well, it's just a perfect square. 9's a perfect square. Z squared is a perfect square. Square root of 9 is 3. The square root of z squared is z. Done. Number 2 is a perfect square. 100 is a perfect square, and v is a perfect square. So simply just 10v. Well, now this one's a little bit more difficult because y cubed is not a perfect square, but 25 is. So we'll just rewrite the 25, and we'll write the y cubed as y squared times y. Now, I'm going to take out my next pen. The square root of 25 is 5, and the square root of y squared is y. So my final answer is 5y square roots of y. Moving on up. Okay. Oh, fractions. Gotta hate fractions. Oh my god, I hate fractions. Just kidding. Let's see what we got. We got 18. Let's see. Perfect square that goes into 18, that would be 9. 9 times 2. Those of you that are still making mistakes with these might want to write them like this. Take the time, don't be lazy, and write them out the way they're supposed to be written out. Show your work. If you're not making mistakes and you're a genius, well, still write them out. Okay, you can skip a few steps. M squared is a perfect square. Now, p to the 5th. I want groups of 2. So I want to get to as close to 5 as I can with using groups of 2 because we're working with square roots. So the closest I can get to 5 is 4 because 4 is actually a perfect square. P to the 4th is a perfect square. And then I got to multiply by p because p to the 4th times p is p to the 5th. Okay. Now that I've taken care of and written everything is either a perfect square or not a perfect square, I can simplify it. The square root of 9 is 3. The square root of m squared is just m. And the square root of p to the 4th is p squared. So my final answer is going to be 1/3 times 3. Well, that's just 1. So I really don't need to put a number down. M p squared square roots of, now take a look, see what's left over underneath that's not canceled. We've got a 2 and we've got a p. In case we want to go to the bathroom. Okay, not really, just kidding. Wasn't funny, I know. My jokes are amazing. X cubed is not a perfect square, so we're going to rewrite it as x squared times x times, and y squared is a perfect square, times y squared. Alright, take out my next pen. The square root of x squared is x, and the square root of y squared is y. So my final answer is x, y, square roots of x. Moving on. I know some of you have done some of these problems in the past or something similar to these. Square root of 27. We're going to rewrite it as 9 times 3. X to the 4th is a perfect square. We'll leave it as x to the 4th times y. Switching pens. Square root of 9 is 3. Put that up there. The square root of x to the 4th is x squared. So my final answer is going to be negative 2 times 3, which is negative 6. X squared square roots of, and then what's left over in the radical is 3y. 3y. All right. A perfect square that goes into 90. Lost my pen for a second. Oops, I forgot the 2/3 out front. Another fraction. Don't get scared. How about 9 times 10? That'll work. And then x is not going to ever be a perfect square, so we'll just rewrite it as x. This isn't even a bad one. There's not much to do on this one. The square root of 9 is 3. Now, I know all of you can multiply 2/3 times 3 and get 2 square roots of 10x. Done. 7/4. That looks actually scary. 7/4. Let's see. Square root of 80. We've done that a few times. Hopefully in your math classes you've done that a few times. And you'll find out that the largest perfect square that goes into 80 is 16. I know 4 goes in, but it's not the largest one. 16 is the largest one. Now x cubed I'm going to rewrite as x squared times x. Y squared is just y squared. That's no problem at all. And z to the 5th we're going to rewrite as z to the 4th times z. Alright, now that I've rewritten everything under the radical as a perfect square or not a perfect square, I can start crossing stuff off. Square root of 16, 4. Square root of x to the square, x to the squared. X squared is x. Square root of y squared, y. Square root of z to the 4th, z squared. Now, 7/4 times 4 is 7. The 4's just cancel. X, y, z squared, square roots of x, z. That's it. Last one. So 2 square roots of. Now 108, the largest perfect square that'll go into 108. Remember we told you to, cut it in half, cut it in half. Cut it in half, you get 54. So just check perfect squares that are less than 54. You'll find out that 36 goes in. 36 times 3. M squared times m. We'll rewrite that as a perfect square and not a perfect square. N squared is a perfect square, so we'll just rewrite that. And then p to the 4th. Alright, the square root of 36 is 6. The square root of m squared is m. The square root of n squared is n. And the square root of p to the 4th is p squared. So I left with the numbers multiplied give me 12. M, n, p squared, square roots of 3m. Alright, let's work on perfect cubes. Now, perfect cubes was new a little bit. The first perfect cube that you'll know of is 1. 1 times 1 times 1 is 1. The next one is 8. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. Now, generally, these are pretty much all you have to worry about. These are going to be the cubes that most of us deal with. I mean, I could do 216 or 729 or 329. I don't know what 7 squared is. Doesn't matter. Nobody remembers those. All right, so what we're looking for with perfect cubes is not groups of 2 anymore, but because this is a 3 out here, and I probably should be doing this in a nice highlighter, because that's a 3 out there, I want to look for groups of 3. With the numbers, I'm looking to see if I can make a number that is a perfect cube and not a perfect cube. With the variables, I'm looking for groups of 3. 3, 6, 9, 12, so on and so forth. In this particular case, 27 is already on my list. It's a perfect square. X cubed has a group of 3. y to the 6th has two groups of 3. It's a y cubed and a y cubed. So this is a perfect cube that's underneath here. The cube root of 27 is 3. The cube root of x cubed is x. And the cube root of y to the 6th is y squared. That one's done. All right, so most of this is a perfect cube, except for the end of the 4th. So I'm going to rewrite it. I know this is time consuming, but you know what? It's nice and neat. It's organized. People can read it. People know what you're doing. M cubed. So all of that is a perfect cube. 125 is a perfect cube. M cubed is a perfect cube. And then we're going to multiply by n cubed times n. All right. All right, so the cube root of 125 is 5. The cube root of m cubed is m. And the cube root of n cubed is n. So I'm left with, now be careful, you want to make sure you write your answers. Let's see if I did that up here. No, I didn't have any perfects. We're going to put a 5m n out front. You got to put a 3 there. And the only thing left under the radical, even though I made a huge radical, is an n. All right, so this one we're going to have to rewrite. Oh, we got a negative. That's scary. Oops, I forgot to write that negative. I was so scared by it, I forgot to write it. Negative 3 cube roots of. Now, I'm going to go through, and I'm going to write these all as perfect cubes and not perfect cubes. Let's see, 16. It's pretty easy. 8 goes into 16, so 8 is a perfect cube times 2. 8 times 2 is 16. A squared can never be a perfect cube because it can never be a group of 3. But b to the 5th can. We can write it as b3. That's 2b. That's 3 b's, and we need 2 more. B squared. Okay. Cube root of 8 is 2. The cube root of b cubed is b. And that's it. So we'll multiply. We get negative 6. That's these two multiplied together. B cube roots of, let's see, we got a 2, we have an a squared left, and a b squared left. That's it. All right, let's see how we do on this one. 3 halves. Cube roots of. Now again, it's 80. The cubes, you know, other than them being a little odd, shouldn't be too difficult. There's not that many perfect cubes to check. We got 8, we got 27, we got 125, we got 64. There's just not that many to check. So 80, clearly 8 goes into 80. 8 times 10. D to the 6th times D. Well, the cube root of 8 is 2. The cube root of d to the 6th is d squared. So these 2's cancel, and I'm left with 3 d squared cube roots of 10d. Okay, next problem. 54. Again, so 54 is odd. 54 is odd. There's no reason to check 2 or 64. Well, 64 can't go in. So that really leaves us one choice, 27. So we're going to rewrite this as the cube root of 27 times 2. And g to the 9th, 9 is a multiple of 3, so that is a perfect cube. G to the 9th. So the cube root of 27 is 3, and the cube root of g to the 9th is g cubed. G, that was easy. Oh, God. You guys are thinking to yourself, I have either the funniest or the dumbest math teacher in the world. Those of you thinking dumbest, I got a drop slip for you. Just drop you right out of my class, man. Right out of it. I don't want you anyway. You rude so-and-so and such and suches. Just kidding. Love you guys all. You guys are great. 8's a perfect cube. I don't even have to look. 8 is a perfect cube. Thank you, Mr. Krause. K to the 6th, perfect cube. Don't have much to do with that. J to the 7th. All right, so we're going to rewrite this as j to the 6th times j. I feel like singing. All the cube root of 8 is 2. It look like I crossed it off. Cube root of k to the 6th, k cubed. I said k cubed. I meant k squared. There are 2 groups of 3 in 6. And there are 2 groups of 3 in this. Let me make sure I didn't screw anything else up, man. That would really be embarrassing. I'm doing good. I'm doing good. It looks like I'm doing good. You find a mistake, you let me know about it. Don't embarrass me now. 1/2 times 2. Well, that's just 1, so I don't have to worry about that. K squared, j squared, cube roots of, don't forget the 3, j. Here we go. 3/4. So we're going to do 3/4 times, look at that, 64 is a perfect cube. I don't have anything to do. It's a perfect cube. Love it. Thank you, Mr. Krause. You're the best. You're the best. Well, I'm not the best, guys, but I'm pretty close. Thanks. I appreciate that. That's just awesome of you guys to think about me like that. Oh, okay. Never mind. Shut up. Q cubed times Q. We want to write it as perfect cubes and not perfect cubes. Okay. The cube root of 64 is 4. The cube root of Q cubed, that's really hard to say, actually, especially for us crazy math teachers. Q is just Q. All right, so 3/4 times 4, the 4's cancel, and I'm left with 3 cube roots of, there's a P that I didn't cross, and there's a Q that I didn't cross out. There's that answer. Moving on down. All right, so it's 250. Now, come on. You know it's not going to be, it ends in a 0. And 5 goes into it, and 25 goes into it. Clearly, this is going to be 125 times 2. W to the 9th, perfect cube. H to the 6th is the perfect cube, but we need one more, so we'll write H. Alrighty. So, the cube root of 125 is 5, because 5 times 5 times 5 is 125. W to the 9th, there are 3 groups there, so that's W cubed. H to the 6th, there are 2 groups of 3 there, so that's H squared. So my final answer is 10, multiplying these 2 times this 5 here. W cubed, H squared, square roots of, cube roots of, the only thing I didn't cross off was a 2 and an H. One left, boys and girls. Let's see, 24. There's only one perfect square. I don't care about one. There's only really one perfect square that's less than 24. So that should be pretty easy. Q. 8 times 3. C cubed times C squared. That makes 5. D to the 9th times D. That makes 10 Ds. Got something in my eye. All right. Cube root of 8 is 2. The cube root of C cubed is C. The cube root of D to the 9th is D cubed. So my answer is 2CD cubed. Cube roots of 3C squared D. All right. Let's multiply with radicals. So we got to multiply, and then we got to look to simplify. Sounds like a lot of talking. All right, so, I don't know where I'm at. Oh, there we go. So when you're multiplying radicals, you multiply the things in the radicals, and you multiply the things not in the radicals. So in this case, I've got a 3 and a 1 outside the radical, so that's just 3, times the square root of 45. But now we're back to square roots, so now I got to look to simplify that perfect square. And I can rewrite that as 3 times the square root of 9 times 5. The square root of 9 is 3, so my final answer is 9 radical 5. Down here it's a negative times a negative, so that's negative times a negative, which is positive 5. Square roots of 20. But I can rewrite the square root of 20 as 4 times 5. Square root of 4 is 2, so this becomes 10 square roots of 5. Now, at some point, you guys should pause this, try these on your own, and then see how you did. Stop watching me perform like a monkey and start looking to see, can I do some of these on my own? Am I capable? I hope so. So let's see what we got here. Okay. 11 times 2 is 22. Square roots of, now we'll multiply the two radicals together. That's 48. Now the largest perfect square that goes into 48, you might think it's 4, but it's 4 times 12. And 12 has a perfect square that goes into it, another 4. So this one actually can be rewritten as 22 square roots of 16 times 3. 48 math teachers love to ask, because most kids forget that 16 times 3 is 48. Square root of 16 is 4. So my answer is 88 radical 3. All right. I know y'all hate fractions, but 2/3 times 12. Multiply the numerators, divide by the denominator. 2 times 12 is 24. Divided by 3 is 8. So I get 8 square roots of 80. And we've already done this one. We know that 16 goes into 80. So this is 8 square roots of 16 times 5. The square root of 16 is 4. So my final answer is 32 radical 5. Negative times negative is positive, so it's positive 15 square roots of 100, because of 20 times 5 is 100. 100 is a perfect square, so that's just 10. So my answer is 150. Negative 5 times nothing. Square roots of 18y to the 4th. Well, I can rewrite that as negative 5 times the square root of 9 times 2 times y to the 4th, because y to the 4th already is a perfect square. Remember, we're back to looking for groups of 2. Perfect squares and groups of 2. Square root of 9 is 3. The square root of y to the 4th is y squared. So I end up with minus 15, y squared square roots of 2. So there's a 1 here. 1 times negative 7 is negative 7 square roots of 40 p squared. Well, the largest perfect square that goes into 40 is 4. You guessed it. So 4 times 10, and p squared already is a perfect square, so we don't have to worry about that. The square root of 4 is 2. The square root of p squared is just p. So I'm left with negative 14 p square roots of 10. All right, 30 times a fifth. Well, what's 1/5 of 30? That would be 6 square roots of 40. And we just simplified the square root of 40, which was nice. It's the square root of 4 times 10. And the square root of 4 is 2. So my answer is 12 square roots of 10. And finally, 2/3 don't have anything to multiply by, so we'll just leave that. I'll bet I have something to do with that at the end. Maybe. Maybe not. Square roots of 24k cubed. Well, the largest perfect square that goes into 24 is 6. So I'm going to rewrite this as 6 times 4 times k squared times k. Perfect squares and not perfect squares. Groups of 2 and not groups of 2. The square root of 4, I should have written that first, is 2. Square root of k squared is k. So I'm left with, well, I don't have any simplifying to do. 2/3 times 2 is 4/3. You multiply the numerators and divide by the denominators. Well, I can't divide, so I'll just leave it. K square roots of 6k. All right, kiddies, adding and subtracting. You would really make your Algebra 2 trig teacher mad if you said that this was the square root of 102. I mean, that is so juvenile to do that seriously, you might just have somebody walk by and smack you around with a yardstick or something, because that's just crazy. Nobody does stuff like that and think, whoa, algebra 2 is so easy. It's not going to work that way, kids. In order to add or subtract radicals, you have to have a common radical, so you have to do some simplifying. This is going to be the square root of 9 times 3. What is the square root of 9? It's 3. So this becomes 3 radical 3. Now there's like a 99.99% chance this one's going to have a radical 3 in it. And if you take 2 seconds to think about it, isn't it 25 times 3? Square root of 25 is 5. So this becomes plus 5 radical 3. And we end up with 8 radical 3 is our answer. All right. I'm just going to go across and then we'll go down. This is 3 radical 16 times 2 minus 6 radical 4 times 2. Wow, that sounded weird. Square root of 16 is 4, so this becomes 12 radical 2. Square root of 4 is 2, so this becomes minus 12 radical 2, and we end up with zippo nada. That's it. This is 10 square roots of 8 can be broken up into 4 times 2 plus, oh, nothing to do with this one. That's nice. Square root of 4 is 2. So this becomes 20 radical 2 plus 3 radical 2, or 23 radical 2. Hey, I wrote that without even looking. I'm freaking amazing. Here we go. Oh dear, Mr. Cross, this is the square root of 122. I'm so smart, 122. Yeah, very smart. Yes, I am. I'm very smart. Get out of my class now. No place for you. I have no chairs for you. I have no time for you. First one's hard, Mr. Krause. I don't know. I want to use 8 and 9. 8 and 9 would be terrible. 50 is just 25 times 2, so I'm going to guess, since this one's going to end up being 5 radical 2, that this one better have a 2 in it. Let's see, 2 times 36, so yeah, 36. And the square root of 36 is 6, so this becomes 6 radical 2 plus 5 radical 2 is 11 radical 2. Remember, it's just like adding up x's. You know, if I had 6x plus 5x, I would say that's 11x. You don't mess with the x. You only take care of adding and subtracting the numbers. Hey, my God, Mr. Krause, it's got 3 here. This is so impossible. But look, it's got a radical 3. So more than likely, these are all going to have radical 3s. And yes, of course they do. 4 times 3 plus square root of 48. We've done that already. 16 times 3 minus radical 3. Let's see. That's a 2. So that's 2 radical 3. That square root of 16 is a 4, so that's plus 4 radical 3 minus 1 radical 3. 6 radical 3 minus 1 radical 3 is 5 radical 3. Oh. All right. This one's just too impossible. So maybe you don't know 98, but you should know 8. And maybe you don't know 128, but you should know 8. 8 is 4 times 2. And the square root of 4 is 2. So this becomes minus 8 radical 2. Well, if I'm going to be able to add all these up, they all have to have a radical 2 in it. So I'm going back up to here and I'm thinking, okay, oh yeah, that's 49 times 2, which is 7 radical 2. And if I come back over here and I go, oh yeah, that's 64 times 2. Square root of 64 is 8. So I get plus 24 square root of 2, because you got to multiply these two together. So 7 minus 8 is negative 1. Plus 24 is 23 radical 2. All right, this one has a radical 2. And this one we can make have a radical 2. Square root of 25 is 5. So I got 5 radical 2 and a radical 2, that's 6 radical 2s. Square Square root of 80, we've done it already a bunch of times. 16 times 5. Square root of 16 is 4. 4 radical 5. This is 9 times 5. Square root of 9 is 3. That's plus 3 radical 5, which gives me 7 radical 5. All right, now this really long, complicated one. Pause this. Try it on your own. If you can do this one, you can do all adding and subtracting with radicals. Pause it. Pause it. All right. Let's see what you did. 9 times 3. 36 times 3. Notice the pattern with the 3's. Plus 2, 25 times 3. Square root of 9 is 3. So this ends up being 15 radical 3. Square root of 36 is 6. This ends up being minus 6 radical 3. Square root of 25 is 5. So this ends up being plus 10 radical 3. 15 and 10 is 25. Minus 6 is 19 radical 3. All right. We're going to talk about this thing called rationalizing the denominator. That's actually pretty good. Never leave a radical in the denominator. Never, ever. Or under a fraction, because that just means it's in the denominator. So, and I know we've talked about this at length in class, and hopefully you have in your math teacher. These are just some refreshers. But I can take anything and multiply it times 1 and never change its value. I could take pizza and multiply it by 1. I still get pizza. It's not changing its value. So that's what we're going to do with all these fractions. We're going to multiply by a weird-looking 1. We're going to write it as a fraction. Now, if it's a fraction and it's 1, it has to be the same thing over the same thing. So in this case, we're going to rewrite it as the square root of 5 over the square root of 5. And if you had to ask yourself, what is the square root of 5 divided by the square root of 5, you would tell me 1. So now I can multiply. You multiply numerators and you multiply denominators. To multiply the numerators, I get 4 radical 5. Now I'm going to take it, I'm a baby step here. Square root of 5 times the square root of 5 is the square root of 25. But isn't the square root of 25 just 5? Because I don't want radicals in the denominator. I should end up with nothing as far as a radical going in the denominator. So the square root of 25 is 5. Well, in the future, anytime you multiply a radical times itself, which is why we are doing this, you end up with no radical. Square root of 3 times the square root of 3 is 3. Square root of 2 times the square root of 2 is 2. Square root of 11.8 times the square root of 11.8 is, you guessed it, 11.8. This one we'll rewrite as the square root of 3 over the square root of 7. Now, the square root of 3 is not a problem. The problem is this silly square root of 7. So we'll rewrite it as the square root of 7 over the square root of 7. Now, in the numerator, you multiply the numerators. You multiply these radicals together. You can get the square root of 21. And the square root of 7 times the square root of 7 is just 7. Done. This one, we're going to have a little bit of work to do. We're going to multiply by the square root of 8y over the square root of 8y. Yes, I could simplify the square root of 8y, and actually that might make my life a little bit easier. I'll just leave it for now. 2 square roots of 8y over 8y. But you have to eventually simplify it, because I still have this thing to simplify. So I'm thinking, because I still have that thing to simplify, maybe that would have been easier to start with. Maybe what I should have started with is just simplifying it right away. 2, 4 times 2y. So this becomes 2 over square root of 4 is 2. So 2 square roots of 2y. Well, the 2's cancel. So I left with 1 over the square root of 2y. Now I'm going to multiply by the common denominator. In this case, the common denominator is 2y. So square root of 2y, square root of 2y. So I end up with the square root of 2y over 2y. And there's my answer. All right, moving down. All right, here we're going to multiply by the square root of 6 over the square root of 6. Well, okay, so I get 12 square roots of 6 over 6. Well, 6 goes into 12 twice, so I end up really with just 2 radical 6. This one is the square root of 3 over the square root of 9. But isn't the square root of 9 just 3? Sure. So I'm actually done. Didn't have any work to do on that one. This one I'm going to multiply by the square root of x over the square root of x. And I get 8 radical x over x. This one I'm going to simplify. I'm going to rewrite it as the square root of 5. And the bottom we're going to rewrite as the square root of 4 times 3. Well, what is the square root of 4? 2. So we're going to rewrite this as the square root of 5 times 2 radical 3. Now the problem is the radical 3 in the denominator. You can't have a radical 3 in the denominator, so that's what we're going to multiply by. Radical 3 over radical 3. So in the numerator I get the 5 and the 3 make 15, so radical 15 all over. Now radical 3 times radical 3 is just 3. Times the 2 gives me 6. Done. 3 over radical 4 times 5. The square root of 5 is 2. So I end up with 3 over 2 radical 5. So again, the problem here is this radical 5. So I'm going to multiply by radical 5 over radical 5. So I get 3 radical 5 over, well, radical 5 times radical 5 is 5, times 2 is 10. And my final one. Nothing to simplify here. It's just crazy xy. So it doesn't matter what's down there. Whatever's down there, that's the thing you got to get rid of. So we're going to multiply by the square root of xy over the square root of xy. And again, this is just a crazy looking 1. And I can do that anytime I want. 3 square roots of xy over xy. All right, 9 left, kids. These are a little bit more tricky, so got a little bit more work to do on these. What we're going to multiply by, and I thought I changed this. This ain't whatever class. We're going to conjugate, not conjugate. We're going to conjugate. In order to do so, first thing you're going to do is put these in parentheses. And again, we're just going to multiply by 1, but we're going to represent 1 in a strange way. We're going to represent it as the conjugate of this one. Well, it's the exact same thing, but with a plus sign. All right. So in the numerator here, we're going to multiply, let's see, 2 times 3 plus radical 5 all over. Now, I got to double distribute here. Now, I'm only going to double distribute once because you're going to find out that this is not that necessary. 3 times 3 is 9. 3 times positive square root of 5 is positive 3 square roots of 5. 3 times negative square root of 5 is negative 3 square roots of 5. Minus, now it's negative square root of 5 times negative square root of 5. We've already talked about this. Radical 5 times radical 5 is just 5. So it's really just minus 5. Well, what happens to these two? Those two will always cancel. Always. So I'm not really going to take the time to double distribute anymore. I'm really just going to multiply the 3's together and the square root of 5's together, because if you multiply by the conjugate, the middles always, always, always drop out. So I end up with, now we got to be careful here, 2 square roots of 3 plus radical 5 over 4. But I'm not done. 2 goes into 4 twice. So my final answer is 3 plus radical 5 over 2. All right, we'll just keep going. We're going to multiply by the conjugate, which is radical 6 minus 2. Radical 6 minus 2. All right. So this gives me radical 5 times radical 6 minus 2 over 6 times 2 is, well, that's just 6. I don't have to do the outsides and insides. And negative 2 and positive 2 make minus 4. So my final answer is radical 5, radical 6 minus 2 over 2. All right, next one. We're going to multiply by 6 plus radical 3. 6 plus radical 3. This one I have a little simplifying to do. 11, and then we're going to do 6 plus radical 3. Now the 6 is multiplied. That gives me 36. Minus, and radical 3 times radical 3 is just 3. So in order to simplify things and save a little bit of time, isn't this just 33? And 11 goes into 33 3 times. So my final answer is 6 plus radical 3 over 3. 6 left. We're going to multiply by 1 minus radical 3 because that's the conjugate. Distribute. We're not going to distribute. We're going to leave it as this because if you distribute, then later on you got to undistribute or factor in order to simplify. So I'll just leave it out there. 1 times 1 is 1. Radical 3 times radical 3 is 3, so it's really minus 3. Well, this becomes negative 2. And doesn't negative 2 go into 10 negative 5 times? So negative 2 goes into negative, or 10 negative 5 times. So my final answer here is negative 5, 1 minus radical 3. Now, could you distribute that? Sure, why not? Oops, I forgot the parenthesis. But, oh. All right, we're going to multiply by this one's conjugate. This one's going to be kind of cool. Freaking math. I said the word cool with math. That's just crazy. Who says the word cool with math? That's not the conjugate. You got to put a plus sign in there. Square root of 3 plus radical 2. So, in the numerator, we're not going to distribute. We're going to leave it as 6. Square roots of 3 plus square roots of 2. In the denominator, we'll multiply the first, which is radical 3 times radical 3, which is just 3. And we'll multiply the radical 2's together. We get minus radical 2 times radical 2 is 2. So this is just 1. Well, then that makes this my answer, because over 1. I don't have to put it over 1. Getting almost done. All right, this one will be kind of nice too. So we're going to multiply by the conjugate. Square root of 7 plus 5. Square root of 7 plus 5. Oh, it's plus radical 5. That makes it even cooler. All right, it's math. Not that cool. But things are going to cancel on this one. So we get 2 radical 7 plus 5. That's a radical 7 plus 5. And now the denominator. It's radical 7 times radical 7 is 7. Minus radical 5 times radical 5 is 2. Or excuse me, is 5. So that's minus 5. Well, 7 minus 5 is 2. And then these 2's cancel. So my final answer, believe it or not, is radical 7 plus radical 5. I don't know why I didn't write a radical over this. All right, I didn't add another page, so I'm going to cram this in here somehow. Radical 7, 3, and 3. So I get radical 2 times radical 7 plus 3 all over. Radical 7 times radical 7 is 7. Minus 3 times 3 is 9. So that's 9 is 9. So this actually turns out to be a negative 2. Well, I can't leave the negative in the denominator, so I'll just put it out front or right in the top. Negative radical 2 times radical 7 plus 3 all over 2. That's kind of a dumb question. All right. We're going to multiply by 5 plus radical 5. 5 plus radical 5. So in the numerator, I get 24 times 5 plus radical 5 all over. 5 times 5 is 25. Minus radical 5 times radical 5 is 5. So this is really just 20. So I got a little bit of simplifying to do. Let's see. 4 goes in here 6 times, and 4 goes in here 5 times. So my final answer is 6, 5 plus radical 5, all over 5. A tricky one. All right. This one will have some nice stuff dropping out. We're going to multiply by radical 15 plus radical 5. Radical 15 plus radical 5. So I end up with 40 times radical 15 plus radical 5. And the denominator, square root of 15 times the square root of 15 is 15. The square root of 5 times the square root of 5 is 5, but so it's minus 5. So the denominator really just becomes a 10. And we know that 10 goes into 40. This would be a 40 4 times. All right, looking right there for the answer. So my answer is 4 times radical 15. 4 times radical 15 plus radical 5. And that's it. That's all she wrote. That's radicals. We got one more left for Unit 4, and then we'll do a practice test as well. Alrighty. That's it. Signing out. Take it easy.